All right, good morning. Here we go. Any specific questions on last night's homework? Nothing? Okay, good. I'm going to call out the answers. It's Friday. I just need you to make sure that you've attached a picture of your work to your assignment, and I will look at your work because today is crazy important. So we're going to get started. There's 2 days of this. This is how this chapter ends, and it ends on a high note. And it ends answering the question, why in the world have we done any of this? What purpose could this solve? It just seems like a worthless skill that wouldn't involve anything. It turns out it actually solves a really big problem. All right, so tonight it's going to be a worksheet. It's already loaded up on Teams. Hey, I noticed, Porter, that you've already turned in your homework, although you literally turned in nothing. Make sure you don't hit the turn in button at the top right-hand side until you attach a picture. I also question whether or not you've actually figured this out all by yourself, but since you didn't attach anything, I'm assuming it's just a mistake. Okay, here we go. Solving quadratic equations by factoring. That's what this was all about. In fact, everything from 5.1 all the way up to 5.11, all are skills involved in this, what we're going to do today, which is called solving quadratic equations. So big day. All right, the last few classes, we've had a quadratic expression, x squared plus 6x plus 8, and we've asked you to factor it. So this one, remember, factors into x plus 2, x plus 4, 4 times 2 is 8, and 4 plus 2 is 6. Those are the nice, easy, friendly ones. By the way, those are the ones that we're going to do today. So we're going to do nice, friendly ones, not the stuff that we've been doing for the last 4 days, the more challenging ones where a doesn't equal 1. So the more challenging ones, the ones that now some of you are getting pretty darn good at, these are also factorable, and I won't go over that process. But point being is that we now know how to factor quadratic, as long as they're factorable, okay? Why did we do all this trouble? Because today we're going to solve quadratic equations. So we've already solved linear equations. Remember way back chapters 2 and 3, I gave you an equation. There's only one variable, x. We solve it. We use a little bit of algebra. We get to an answer. So the reason why one of the reasons why we factor is that it allows us to solve a quadratic equation. So my claim is now, notice the difference, now we have an equal symbol. All the way up to today, there's been no equal symbol in chapter 5. But now we're going to have an equal symbol. We may even have something on the other side. So now we're going to take this equation and we're going to solve it. So you're like, wow, how would I even do that? What would I do? And it turns out today I'm going to teach you a pretty nifty trick. Okay, it's still algebra that I'm going to teach you, but we're going to arrive at an answer. And it's absolutely crazy. It's a new idea. All right, so think about this. Way back, I don't know, 2nd, 3rd, 4th grade, when you first learned multiplication, you had problems that looked like this, where they gave you a number, they put a blank spot, and they put an answer right here. Well, now I'm going to give you 2 blanks, right? And notice the answer here equals 0. So what in the world could possibly go on either one of those blank spots? Well, I'll go ahead and answer the question. What has to go there? There's only one way to get to 0 through multiplication. And that was either the first number has to be 0, or the second number has to be 0, or third choice, everything is 0. These are the only possible ways to get to 0. Either the first thing has to equal 0, 0 times, I don't care what number you put here, 0 times anything is 0, or anything times 0 is 0, or 0 times 0 is 0. Those are the 3 possible ways. This actually has a name to it. This is called the zero product property. The zero product property states that when 0 is multiplied by anything, the result is 0. Now, this certainly doesn't look like factoring, and it doesn't look like solving. And it turns out this is the property that's going to allow us to solve these quadratic equations. All right, so I'm going to have to explain how all that works. All right, so I'm going to use the zero product property to solve a quadratic equation. So I want to solve for x. Well, before we tried to get x's on both sides. Well, they're on both sides, and then we moved numbers around. Well, it turns out there's an easier way as long as it's a quadratic equation. So if it's a quadratic equation, you are allowed to use this trick, and here comes the trick. The trick is factor it. So what we're going to do is we're going to factor it. Now, I do need to point out one thing to start with. Notice that this says x squared plus 5x minus 6 equals 0. In order for this trick to work, the equation must always, always, always equal 0. If it doesn't equal 0, you can't use this trick. However, sometimes the equation will not equal 0. Check it out. It says x squared plus 5x minus 6 equals 2. If the equation doesn't equal 0, we can use a little bit of algebra to make it equal 0. I can simply subtract 2 from both sides. I get a different quadratic equation, but check it out. Now it says equals 0. So step number 1, if your quadratic equation does not say equals 0, you got to force it. You got to make it equal 0. So we'll save that one for a little bit later, but I do want to point out from the very start, it must equal 0. So here we go. Here's how this works. Okay? I'm going to give you a quadratic equation. It's going to be equal to 0. Step number 1 is you're going to factor this. So remember factoring this. Remember, a doesn't equal 1, so we're not doing that a times c thing yet. We'll save that for a different day. These are the nice simple ones, the ones that you can do very quickly. We're looking for two numbers that multiply that equal -6 that add up to +5. Well, those two numbers will be 6 and -1. 6 times -1 is -6. 6 plus -1, or 6 minus 1, equals +5.
Oh, so you just want us to put it back to its like original form?
I just want you to factor it, right? And these are the easy ones to factor. Now, this is the magic. This step right here, notice I've got this times this equals 0. This looks exactly like the previous thing when I showed you the zero product property, which if anything times anything is 0, that means one of three things. It either means that this thing, this whole thing is equal to 0, or this whole thing equals to 0, or they're both equal to 0. This is how easy this will be. We will take the first thing or the second thing or both, and we will set them both equal to 0. That's the zero product property. Why? Because when two things multiplied equal 0, one of these or both have to equal 0. So we're going to assume that both equal 0. So all we do now, watch how easy this will be. I take the first thing and I set it equal to 0. I take the second thing. What's the second thing right here? And I set it equal to 0, and I solve both of these independently. Well, I don't need the parentheses anymore. And by the way, it's just going to be a one-step equation, really simple. Add 1 to both sides to this one, and you get x equals 1. Subtract 6 from both sides, and you get -6. And ladies and gentlemen, here are the two answers. Literally, it looks like this would be the hardest thing to do to solve this. It turns out this is the easiest. Quadratics are really easy to solve. Quadratics, you just factor them, set them both equal to 0, and solve. You're going to have to see this a few times. So once again, the answer was -6, 1. I'll show it to you. And it's either number. Check it out. 1 squared is 1. 5 times 1 is 5. 1 plus 5 is 6. 6 minus 6 is 0. So 1 is one of the answers. -6 squared is 36. 5 times -6 is -30. 36 minus 30 is 6. 6 minus 6 is 0. Both of these numbers make this true. So that was a check step. So once again, I'm just going to show you the zero product property, just that part of it. So the zero product property, once you factor your quadratic, it will always look something like this. You simply take the first thing, you set it equal to 0. You take the second thing, and by second thing I mean the second thing in parentheses, you set it equal to 0, and you solve both of them. And when I say solve, I don't mean much work. You just move the 4 to the other side. You move the 2 to the other side. Subtract 4 from both sides, you get -4. Add 2 to both sides, you get +2. We do put the answers in order from least to greatest. We use these braces to write our answers. So the two answers are -4 and +2. This is really simple to do if you can factor. Okay, once again, the other type of thing that can happen is when we factor one of those special case ones and we get literally the same thing, x plus 4, x plus 4. In this particular case, well, both of them say x plus 4. I don't need to set both of them equal to 0. Just one of them will be work. Subtract 4 from both sides, so we get -4 is the answer. So sometimes you will only get one answer. Now, if it's not factorable, you'll get 0 answers. All right, let's see this again. Once you factor it, I'm skipping the factoring step for the start here. The first, I think, third of the homework, I have them set up like this, equal to 0. All you do is you take the first thing, set it equal to 0. That's using the zero product property. Take the second thing, the second binomial, set it equal to 0, and solve each one separately. You get rid of plus 10 by subtracting 10 from both sides. There's not much work to do here. You add 1 to both sides. Some of you, is Josie online right now? How about anyone else? Anyone else know the pattern to go from here to here? Here's the answer. Here's the start. Guess what the pattern is?
It's the opposite.
It's the opposite. Now you got to be careful because I'll soon show you more complicated ones. But for these simple ones, when there's no number attached to x, no leading coefficient attached to x, it's just the opposite of these two answers. It's pretty simple. Okay, the more challenging ones, that's not the case. So here's a more challenging one. This would have been one like when we factored a quadratic where a does not equal 1. So you get some weird stuff that looks like this, like last night's homework, okay? The zero product property doesn't change. We still take the first binomial, set it equal to 0. We take the second binomial, set it equal to 0. Now, granted, this is going to take us 2 steps to get to. This is going to be a 2-step equation. So the first one here, we subtract 6 from both sides. The last step, we divide both sides by 2. Hopefully you're following along. And we get x equals -3. Anyone lost in what I just did there? I just did both steps without showing you the step. The second one, 2-step equation again, add 12 to both sides, divide both sides by 4, and the final answer, -3, +3. Anybody lost in what I just did right there? And yes, it turns out that all that work we've done for the entire chapter culminates in this nice, easy process to solve a quadratic equation. This is also why they don't tell you that from the very start, because you would think it would be an impossible task. And it turns out it's a pretty easy task. Now be careful, you can get some really ugly answers here. Don't be surprised tonight for homework you get some ugly answers. If we take the first one, binomial, set it equal to 0, and the second, and then we solve this one, we would subtract 7 from both sides. And notice when we divide by 2, we're going to get a really ugly fraction, but that's okay. Right? You would get -7/2 if we divide both sides by 2. We add 1 to both sides, and then divide by 4, we get 1/4. It's okay to get fractional answers. It will happen. Am I going too fast, or are you guys catching on? No reply. That means we must be doing okay. All right, one last one for these ugly ones. Once again, once it's in factored form right here, you take the first binomial, set it equal to 0. You take the second binomial, set it equal to 0, and you solve each one. Add 4 to both sides, divide by 2. Add 9 to both sides, divide by 3. So the answer is 2, 3. 2, 3. We okay? All right. Even the weird ones, remember this would be like last night's homework when you factor that first one and it looks like this. Check it out. I still have something times something. So even this is the zero product property. That would be this thing right here. Oops, sorry. That would be this thing right here is your first thing, and your binomial is your second thing that you would solve. So that when we set these equal to 0, we get 2x is equal to 0. And the second one, the binomial, 3x minus 9. You solve both of these. Divide both sides by 2, and you get 0. Not very interesting answer. The second one, add 9 to both sides. Divide by 3, and we get 3. Notice I'm skipping a bunch of steps because by now you guys are really adept at doing, 1 and 2-step equations. By the time we move to geometry and higher math next year, you will rarely see me actually show the steps of solving algebra. Okay, so 0 and 3 are the two answers. All right, so here's what I want you to do. On your own, real quickly, I want you to write down the answers. It should take you all of 1 minute to do all of these. The last one here, you're going to get some really ugly fractions as an answer. Everybody okay to get started?
Yeah.
So, like, I just missed the whole front of this, but what are we supposed to do?
You take each binomial, you set it equal to 0, because think about it. I've got two things multiplied together that are 0. What's the only way that that could happen is if one or both of these actually equals 0. The only way you get to 0 when you multiply is when you multiply by 0. So that, so that either means that x equals 0. I'm sorry, that either means that this thing equals 0 or this thing equals 0. So take each one separately, set them equal to 0, and solve. It'll just be a 1 or a 2-step equation. It'll be really simple to do. And this is called the zero product property. All right, for those of you that got this, continue working. For those of you stuck, let me give you some help here. I take this first one, x minus 1, I set it equal to 0. I add 1 to both sides, I get 1. The second one, set x plus 4 equal to 0, subtract 4 from both sides, I get negative 4. For these nice simple ones, notice it turns into the opposite of these two numbers right here. Instead of 4, the answer is negative 4. Instead of negative 1, the answer is positive 1. Those are the easy ones. The more complicated ones, this one right here, you got to take each one separately, set it equal to 0. 2x plus 10, set that equal to 0 and solve. And then take the second one, x minus 3, set it equal to 0 and solve. Well, that's the second one's easy. Add 3 to both sides, and you get 3 as an answer. The first one, if we subtract 10 from both sides, arrow means this turns into, subtract 10 from both sides, we get 2x is equal to negative 10. Divide both sides by 2, and we get the second answer, which is negative 5. So there is your answer, negative 5, comma 3. How about that with using just the mouse? So negative 5, 3. The next one, we set that equal to 0, and we set that equal to 0, and we solve. So we get negative 3x equals 0, divide both sides by negative 3, and we get 0 as one of the answers. The second one, we set negative 2x plus 6 equals 0. Subtract 6 from both sides, we get negative 2x equals negative 6. Divide both sides by negative 2, and we get x is equal to 3. So there are your two answers for that one. Okay. And your last one, these are the ones with the ugly fractions here. All right, so we set 3x plus 8 equal to 0. This one's going to give me an ugly fraction. Subtract 8 from both sides. We get 3x equals negative 8. Divide both sides by 3. Just leave it in fraction form. We get x equals negative 8 over 3. Second one, 4x plus 5 equals 0. Subtract 5 from both sides. We get 4x is equal to negative 5. Divide both sides by 4. We get x is equal to negative 5/4. Oh, ugly, ugly, ugly fractions. But those are the answers. Questions? Tonight for homework, I don't know what I gave. I think it's 1 through 4. Maybe it's 1 through 5. The first ones will look exactly like this right here. I will give you ones that look like this. You'll simply set each binomial equal to 0, solve, write your 2 answers. Now, when we put it all together, we will be doing some factoring. The rest of the homework is you're going to do the whole darn process. You're going to factor first, then you're going to set each binomial equal to 0 and solve. So this is how you solve it. I just want to point out, we are solving this quadratic equation. If I had showed you this at the start of the chapter and said, how do you solve it? You know, we would have been completely, totally lost. But right now, since we now have those skills, it's not that big of a deal. So remember, when you factor the simple ones, remember this is the one where A equals 1. There's a 1 right there. These are the easy ones. We don't have to do that A times C and then the parentheses, parentheses, parentheses stuff. We will eventually, but we'll do the easy ones first. We'll do the hard ones on Monday. All right, so this one right here, we're looking for two numbers, right, that multiply to 12 that add up to 7. Give me 2 numbers that multiply to 12 that add up to 7. Anybody?
Three and 4.
3 and 4. 3 times 4 is 12. 3 plus 4 is 7. Pretty easy to do. Now, if you couldn't do that, you'd go through all the factor pairs. 1 and 12, 2 and 6, 3 and 4. Only one of these, this one right here, adds up to your B value, right? So that is what goes smack dab there. These are the nice easy ones. We set both of these equal to 0, the 0 product property, and we solve each one. Hey, that one's easy, -3. We solve this one. Hey, that's equal to -4. This is a really simple I'm going to claim that this is easier to do than a 2-step equation. Like you're solving a quadratic, and it turns out it's actually easier than it is to actually solve a 2-step equation. At least that's my claim. Let's do another one. Give me 2 numbers that multiply 7 that add up to 8.
1 and 7.
See how quickly you guys are going to be doing this? Right? 1 times 7 is 7. 1 plus 7 is 8. So that's it. So we throw these 2 numbers, right, into our answer, a 1 and a 7. The ones where A equals 1, these are really simple to do, right? Therefore, tell me the answer even before we do the work. Somebody? What's the final answer? Set both equal to 0 and solve.
-1, -7.
Isn't that easy? Right? For those of you that can't do that in your head, we set each one equal to 0 and we solve. Subtract 1 from both sides, we get -1. Subtract 7 from both sides, we get -7. We put them in numerical order from least to greatest with these braces, -7, -1, and we're done. Man, these are easy. All right, and they're kind of fun. All right, it gets more challenging when I throw some negatives in. So when you throw some negatives in, you just got to be careful. We're still looking for 2 numbers multiplied that are -8, right? That add up to +2. -8 adds up to +2. Who's got it? Well, if you don't have it, then we go through every single possibility. 1 times 8,
-4.
2 times 4.
-2, -4.
And remember, we're going to go through every single possibility. So -2 plus 4 is your +2. -1 plus 8 is a +7. We also could have considered -8 and +1. That would be -7. -4 and +2. That would be -2. So the one that works is this one right here. Right? I still, to this day, I typically write this down as scratch work off to the side, just so I can visually look at it, confirm that 4 minus 2 is 2. Okay, 8 minus 1 is 7. No, I don't want that one. I want this one. So these are all the possibilities to get you to a -8, but only one of them, this one right here, right, that one right there, that's the one that adds up to +2. So in blue here is what I would recommend. I mean, I'm going to have kids that can do this in their head really quick. Like, they'll do the whole thing, and they will get to the answer, the final answer in their head. Other kids, right, you're going to need to write this down, look at it. You're going to need to write this step, and then you're going to need to set each one equal to 0 all by itself. Hey, add 2 to both sides. Hey, subtract 4 from both sides. We add 2 to both sides, we get a +2, we get a -4. So don't worry if you can't do the whole thing in your head. I mean, that's not the goal here, to do it in our head. But there are definitely some kids that can do this whole thing in their head. When I say solve this quadratic, they'll tell me -4, +2, because they're doing this whole thing in their head. So good on you if you can do that. All right. Once again, the ones with the negatives gives us a little bit of problem. Remember, to get to a +9, you can get it two ways. 1 times 9, 3 times 3, or -1 times -9. So remember, when this one is positive and this one is negative, the answer is going to, well, the two factor pairs are both going to be negative. So we need to consider the negative one. So -1 times -9, or -2 times, I'm sorry, -3 times -3. And I think you can see that, well, that would give me a positive 9, but I'm never going to, when I add these together, get to a -6. So I'm not going to consider the positive ones, I'm going to consider the negative ones. And this last one here, -3 minus 3 is -6. So that's the one I'm going to use. Hopefully for now you're already racing to the answer, right? Do I need to set both of these equal to 0? No, because they're exactly the same. So there's only one answer here. By the way, this is one of those special case ones. Remember when I made the statement that you'll be doing a special case one, you won't even realize it until you get to the answer? Oh, it's a special case. So x minus 3 equals 0 turns into just one answer, 3. And check it out. 3 squared is 9. -6 times 3 is -18. 9 minus 18 is -9. -9 plus 9 is 0. It works every time. It's crazy how easy it is to solve these quadratic equations when they are factorable. Okay? All right, one more. Let's see, +10, and this is negative, so I should be considering the negative values. Let's see, 1 and 10 and 2 and 5. 1 and 10 and 2 and, oh, there's nothing else that equals 10. And notice that that's not going to give me a -6. That's not going to give me a -6. So guess what, people?
It's a prime equation.
Yeah, this one is an unfactorable equation, prime, right? This one, it does have an answer, by the way, but this one is not factorable. So we will not be able to solve this one right now. So there will be, I forget, I'll look at the worksheet before I let you go and tell you how many are unfactorable. But this one you can certainly put not factorable. All right, I have 4 of them here. I want you to do 2 of them. Pick 2 and do the whole darn thing. Pick 2 and do the whole darn thing. All right, help people out. Let's see. The first one would factor what time? That would be an x plus 1, x plus 2. 1 times 2 is 2. 1 plus 2 is 3. Second one, 30 that adds up to 11. Let's see. 1 and 30, no. 2 and 15, no. 3 and 10, no. Oh, 6 and 5. So x plus 6, x plus 5. This one, we got to get to a -21 that adds up to a +4. Let's see. 1 and 21, no. 3 and, oh yeah, 3 and 7. So x plus 7, because I want it to be positive, the big number, and x minus 3. 7 times -3 is -21. 7 minus 3 is +4. And this one, negative. So I need a positive and a negative. 1 and 15, no. 3 and 5, no. 3, oh man, this one looks unfactorable. UNF, unfactorable. All right, Aiden, pick the first one, second one, and the third one. Tell me the final answer.
Okay, one sec. Okay, so the second one.